Hello everyone, welcome to the series experiment performance of a triple E subject from second year mechanical course concerned with the Savitribai Phule Pune University. I am Professor V.A.Gajdhane welcomes you all. I am working as an assistant professor in the Department of Electronics and Telecommunication Engineering from PSSM's Dhirubhai Sawant College of Engineering and Research, Nare, Pune. Today, in this video series, we are going to conduct an experiment number 6. The name of the experiment number 6 is speed control of DC shunt motor by field resistance control. Okay, means by controlling the field resistance, we can control the speed of the DC motor. So, what are the learning objectives of this experiment? So, the learning objective is to introduce the students to the speed control methods of a DC shunt motor and what is the outcome of that experiment. So, after the completion of the experiment, students will be able to understand the speed control methods of a DC shunt motor. And students actually in this video lectures in this experiment performance series we will perform today's practical on virtual lab. That virtual lab is developed by the IIT Indian Institute of Technology. Okay, so this is the virtual setup and the connection procedure of the circuit. So actually it is a virtual tool. Okay, so this is the virtual setup. Actually you will get the overall idea over here. This is the voltmeter, this is the ammeter. Okay, this is nothing but the DC motor, and this is the field resistance, and this is the armature resistance. So each and everything is included in this setup. And how we are going to make a connections point to point. Okay, this is explained in this scenario. Okay, so the connection all dots in the following manner. So here point A is connected to the point K. Then through all these process, whenever we are going or we are making the connections, at that time the circuit connections diagram will be looks like this one. Okay, will be looking like this one. So students, we are going to perform this experiment on virtual tool. Go to the virtual lab. Virtual labs website is there. So in that electrical engineering, and by selecting the electrical engineering there are so many subjects, and you have to select electrical machines. Okay, electrical machine simulations, and then go to the electrical machines simulation. In that experiment you have to select the speed control of a DC motor by field resistance control. So we have already discussed about the aim. Now we're going to see some theory about this part. Okay, so we all know that the speed of a shunt motor is given by N is equals to V minus Ia into Ra divided by K into phi, where Va is nothing but the voltage applied across the armature and phi is the flux per pole and is proportional to the field current. Okay, as explained earlier, armature current Ia, we all know that the armature current is denoted with the help of letter Ia, is decided by the mechanical load present on the shaft. Means the value of Ia, okay, armature current is decided by the mechanical load present on the shaft. Therefore, by varying the Va, if we can vary the value of N is nothing but the speed. Okay, so there are two different types of the methods through which we can control the speed of a DC motor. First one is nothing but the armature resistance, and second one is nothing but the field resistance. But here in this video lecture series, we're going to perform the speed control of a DC motor by field resistance control. So this is the circuit diagram actually, or equivalent circuit of the field control of a DC motor. Okay, so this is the motor. Here is the voltage supply. resistance is connected in series with the motor, that is the RA. Then this is the field connection actually connected over here, that is the RC and RSH are connected in series with each other. So this is the equivalent circuit of a field control of DC motor. And here you will get the nature of the graph of torque speed characteristics of a DC motor in this manner. Okay, the speed is over here and this is the torque. Now actually how it is simulated, we are going to see with the help of the simulation part. So by just clicking the simulation part, okay, here you will get, click here to go to the simulation page. Next, I am clicking on that simulation page. Then one window will be open in the separate tab. Okay, so this is the actual virtual connections where you have to make all the circuit connections over here. And we all know that there is a something procedure to connect the points. Okay, and you will get that connections from here. You will get the pointer just to the instruction and you will get all the connections to which means to which pointer is to be connected. So here first of all we have to connect A point to the K point. Okay, so this is the A point. Just clicking the left key of your mouse. Okay, a wire is to be appearing over there. So A is connected to the K over here. Okay, this is the K. So A is connected to the K. Next one, A is connected to the Y. Again, from A is connected to the Y. Okay. Next one, A is connected to J. A is connected to J over here. This is nothing but the voltmeter supply. Then B is connected to the P point. This is the B point. B is connected to the P point. Okay. So this is the indicator. Next, E is connected to the young. Where is the E? Here is the armature resistance point. Okay, E is connected to the young because we have to measure the current along this field resistance. So E point is connected to the young. Next point, F is connected to the point D. Here is the F point is connected to the point D over here. Remember this one, field resistance and armature resistance are nothing but the two different types of the variable resistance over there. And variable resistance is having two different types of the terminals. One is fixed terminal, that is nothing but the E and G terminal. Okay, these are the fixed terminal. But the variable terminals are F terminal as well as H terminal over here. Okay, means we can vary this knob. Okay, we can vary this knob. That's why this F and H, these points are the points connected to the variable terminals, where E and G are fixed terminals. Next instruction is what? F is connected to D over, then G is connected to R. This is the G is connected to the R. Next one, H is connected to the I. H is connected to the I for measuring the voltage. Then I is connected to the C. Okay, this is the I is connected to the point C. Yes. Next one, C is connected to the H. C point is connected to the H point over here. Then Q is connected to the point L. Q point is connected to the L over here. So I think connections are over. So I'm just checking. Okay. So students, by making the connections, we are switching on the MCB supply. So whenever we are switching on the MCB supply, and we have to give one little bit amount armature resistance over here, and then we will have to vary this field resistance over here, because the our aim is to control the speed of a DC shunt motor by varying the field resistance. So we have to vary this field resistance. So initially it is at 0. So I have, if I have to add the reading to my table, the table is showing over here. So by just clicking the add to table, so this is my first reading, add to the table. Next one, this is my first reading. Here our motor is going to start, okay, on its full speed. The speedometer shows the value of motor is nothing, means the value, sorry, the motor is running at 2500 rpm. So we have to add this value to the table. Okay, so this value is added to the table over here. Next one, the speedometer shows the RPM is 2340. Add to the table. In this way, we have to follow all the steps. Add to the table. Then add to the table. This is the fifth reading. In this way, we have to continue reading till last 10th reading. Okay, and finally, we will get here the observation table as current A, okay, current in ampere versus speed in rpm. So this is the procedure to take the readings of this experiment. Next one, with the help of this observation table, we have to draw or we have to plot a graph. So plot is graph in between current and speed. So by just clicking the plot graph, okay, by just clicking the plot graph, you will get, actually this is the plot of speed versus current of a DC shunt motor. Actually, whenever you are increasing the current, okay, as from observation table also you will get the finalized value, that whenever we are increasing the current, okay, initially current is 0, speed is 0, but whenever you are increasing the current to the 0.1, then at that time speed is 2500 rpm. It is too much high. Okay, next, whenever you are increasing the current to the 0.2, the speed will decrease and it will become 2340. Then whenever you are increasing current to the 0.3, then speed is again decreasing, it comes to the 2100. Okay, so in this way our graph is decreasing. Okay, means here from this graph we can observe that whenever the current is going to increase in a DC shunt motor, okay, the speed is also decreasing. Okay, the speed is also decreasing as the current is increasing. Okay students, so in this way we can control the speed of a motor by controlling the field resistance. Okay, thank you students.